The Indian Space Research Organisation, ISRO, is the national space agency of India. It operates as the primary research and development arm of the Department of Space, DOS, which is directly overseen by the Prime Minister of India, while the chairman of ISRO also acts as the executive of DOS. ISRO is primarily responsible for performing tasks related to space-based operations, space exploration, international space cooperation and the development of related technologies. ISRO is one of the 6 government space agencies in the world that possesses full launch capabilities, can deploy cryogenic engines, can launch extraterrestrial missions and operate a large fleet of artificial satellites. ISRO is one of the 4 government space agencies to have soft landing, uncrewed, capabilities. ISRO was previously known as the Indian National Committee for Space Research, INCOSPAR, set up under Jawaharlal Nehru in 1962 recognizing the need for space research. INCOSPAR grew and became ISRO in 1969, within the Department of Atomic Energy, DE. In 1972, the Government of India set up a Space Commission and the DOS, bringing ISRO under it. The establishment of ISRO thus institutionalized space research activities in India. It has since been managed by DOS, which also governs various other institutions in India in the domain of astronomy and space technology. ISRO built India's first satellite, Aryabhat, which was launched by the Soviet space agency Interkosmos in 1975. In 1980, ISRO launched satellite RS-1 on board SLV-3, making India the 7th country to be capable of undertaking orbital launches. SLV-3 was followed by ASLV, which was subsequently succeeded by the development of many medium-lift launch vehicles, rocket engines, satellite systems and networks enabling the agency to launch hundreds of domestic and foreign satellites and various deep space missions for space exploration. ISRO has the world's largest constellation of remote sensing satellites and operates the Gagan and IRNSS, NAVIC, satellite navigation systems. It has sent 3 missions to the Moon and 1 to Mars. ISRO's programs have played a significant role in the socio-economic development of India and have supported both civilian and military domains in various aspects including disaster management, telemedicine and navigation and reconnaissance missions. ISRO's spin-off technologies also have founded many crucial innovations for India's engineering and medical industries. History. Formative years. Modern space research in India can be traced to the 1920s, when scientist S.K. Mitra conducted a series of experiments sounding the ionosphere through ground-based radio in Kolkata. Indian scientists like C.V. Raman and Meghnad Sahar contributed to scientific principles applicable in space sciences. After 1945, important developments were made in coordinated space research in India by 2 scientists, Vikram Sarabhai, founder of the Physical Research Laboratory at Ahmedabad, and Homi Bhabha, who established the Tata Institute of Fundamental Research in 1945. Initial experiments in space sciences included the study of cosmic radiation, high-altitude and airborne testing, deep underground experimentation at the Kolar mines, one of the deepest mining sites in the world, and studies of the upper atmosphere. These studies were done at research laboratories, universities, and independent locations. In 1950, the Department of Atomic Energy, DE, was founded with Bhabha as its secretary. It provided funding for space research throughout India. During this time, tests continued on aspects of meteorology and the Earth's magnetic field, a topic that had been studied in India since the establishment of the Colaba Observatory in 1823. In 1954, the Aryabhatta Research Institute of Observational Sciences, ARIES, was established in the foothills of the Himalayas. The Rangpur Observatory was set up in 1957 at Osmania University, Hyderabad. Space research was further encouraged by the Government of India. In 1957, the Soviet Union launched Sputnik 1 and opened up possibilities for the rest of the world to conduct a space launch. The Indian National Committee for Space Research, INCOSPAR, was set up in 1962 by Prime Minister Jawaharlal Nehru on the suggestion of Dr. Vikram Sarabhai. Initially there was no dedicated ministry for the space program and all activities of INCOSPAR relating to space technology continued to function within the DE. IOFS officers were drawn from the Indian ordnance factories to harness their knowledge of propellants and advanced light materials used to build rockets. HGS. Murthy, an IOFS officer, was appointed the first director of the Thumba Equatorial Rocket Launching Station, where sounding rockets were fired, marking the start of upper atmospheric research in India. An indigenous series of sounding rockets named Rohini was subsequently developed and started undergoing launches from 1967 onwards. Vaman Dattatreya Patwardhan, another IOFS officer, developed the propellant for the rockets. 1970s and 1980s. Under the government of Indira Gandhi, INCOSPAR was superseded by ISRO. Later in 1972, a Space Commission and Department of Space, DOS, was set up to oversee space technology development in India specifically. ISRO was brought under DOS, institutionalizing space research in India and forging the Indian space program into its existing form. India joined the Soviet Intercosmos program for space cooperation and got its first satellite Aryabhatta in orbit through a Soviet rocket. Efforts to develop an orbital launch vehicle began after mastering sounding rocket technology. The concept was to develop a launcher capable of providing sufficient velocity for a mass of 35 kilograms, 77 pounds, to enter low Earth orbit. It took 7 years for ISRO to develop satellite launch vehicle capable of putting 40 kilograms, 88 pounds, into a 400 kilometer, 250 miles, orbit. An SLV launch pad, ground stations, tracking networks, radars and other communications were set up for a launch campaign. The SLV's first launch in 1979 carried a Rohini technology payload but could not inject the satellite into its desired orbit. It was followed by a successful launch in 1980 carrying a Rohini Series 1 satellite, making India the seventh country to reach Earth's orbit after the USSR, the US, France, the UK, China and Japan. RS-1 was the third Indian satellite to reach orbit as Bhaskara had been launched from the USSR in 1979. Efforts to develop a medium-lift launch vehicle capable of putting 600 kg, 1,300 pounds, class spacecrafts into 1,000 km, 620 miles, sun-synchronous orbit had already begun in 1978. They would later lead to the development of PSLV. The SLV-3 later had 2 more launches before discontinuation in 1983. ISRO's Liquid Propulsion Systems Center, LPSC, was set up in 1985 and started working on a more powerful engine, Vikas, based upon the French Viking. 2 years later, facilities to test liquid-fueled rocket engines were established and development and testing of various rocket engines thrusters began. At the same time, another solid-fueled rocket-augmented satellite launch vehicle based upon SLV-3 was being developed, and technologies to launch satellites into geostationary orbit, GTO. ASLV had limited success and multiple launch failures. It was soon discontinued. Alongside, technologies for the Indian National Satellite System of Communication Satellites and the Indian Remote Sensing Program for Earth Observation Satellites were developed and launches from overseas initiated. The number of satellites eventually grew and the systems were established as among the largest satellite constellations in the world, with multi-band communication, radar imaging, optical imaging and meteorological satellites. 1990s. The arrival of PSLV in 1990s became a major boost for the Indian space program. With the exception of its first flight in 1994 and 2 partial failures later, PSLV had a streak of more than 50 successful flights. PSLV enabled India to launch all of its low Earth orbit satellites, small payloads to GTO and hundreds of foreign satellites. Along with the PSLV flights, development of a new rocket, a geosynchronous satellite launch vehicle, GSLV, was going on. India tried to obtain upper stage cryogenic engines from Russia's Globcosmos but was blocked by the US from doing so. As a result, KVD-1 engines were imported from Russia under a new agreement which had limited success, and a project to develop indigenous cryogenic technology was launched in 1994, taking 2 decades to reach fulfillment. A new agreement was signed with Russia for 7 KVD-1 cryogenic stages and a ground mock-up stage with no technology transfer, instead of 5 cryogenic stages along with the technology and design in the earlier agreement. These engines were used for the initial flights and were named GSLV Mk.1. ISRO was under US government sanctions between the 6th of May 1992 to the 6th of May 1994. After the United States refused to help India with Global Positioning System, GPS, technology during the Kargil War, ISRO was prompted to develop its own satellite navigation system IRNSS, which it is now expanding further. 21st century. In 2003, when China sent humans into space, Prime Minister Atal Bihari Vajpayee urged scientists to develop technologies to land humans on the moon, and programs for lunar, planetary and crewed missions were started. ISRO launched Chandrayaan-1 in 2008, purportedly the first probe to verify the presence of water on the moon, and the Mars Orbiter mission in 2013, the first Asian spacecraft to enter Martian orbit, making India the first country to succeed at this on its first attempt. Subsequently, the cryogenic upper stage for GSLV rocket became operational, making India the sixth country to have full launch capabilities. A new heavier lift launcher LVM-3 was introduced in 2014 for heavier satellites and future human space missions. On the 23rd of August 2023, India became the first country to successfully land a spacecraft near the lunar South Pole as the ISRO successfully completed its third moon mission. Indian moon mission, Chandrayaan-3, translated as Mooncraft in English, saw the successful soft landing of its Vikram lander at 6:04 p.m. IST, 12:34 GMT, near the little explored region of the moon, in a world's first for any space program.